Right, we're going to use electricity to extract aluminium, such an important metal in modern society, and a metal that we've kind of got used to and we take for granted, but it hasn't really been around for a long time. Or rather, it has been around. It's the most abundant metal in the Earth's crust. But in the 19th century, it was more expensive than gold. And it's essentially because it was very hard to extract, it was very hard to isolate. However, along came electricity and people developed processes by which the quantity of aluminium that could be processed, that could be produced, became significant and the cost of the aluminium dropped dramatically. Okay, so to make aluminium, and this is still true nowadays, you need large quantities of cheap electricity, which is why typically it's made in countries that have got a very good supply of electricity, and they can use that, especially at night time and times when there's not as much need from the population. They can use the extra electricity they have to make these metals. Okay, so it's still a relatively expensive metal, but it can be made on a large scale, and we're seeing it more and more in planes and bicycles and cars, etc., in the form of alloys. The name of the ore of aluminium is one of those words that you won't forget. For some reason, it just sticks in your mind. It's called bauxite. Bauxite. And bauxite is typically a mixture of aluminium oxide, which is white, and iron 3 oxide, which is red. You think of the colour of Mars. Mars has got a very high proportion of iron oxide. Okay, so this is what it looks like when it's brought out of the ground. It's a powder, a red powder, which is a mixture of these two oxides. Okay, bauxite. Before we can obtain aluminium, we have to purify the ore. Remember, an ore is a rock or mineral that comes out of the ground. And we use sodium hydroxide solution to purify this ore. Now, how does this work? Well, if you add sodium hydroxide solution to the ore, which is a mixture of aluminium oxide and iron 3 oxide, only the aluminium oxide reacts. Okay? So it reacts in this way. It forms this wonderful sodium aluminate. And we have to balance that equation. Balancing looks like that. Okay? So what happens here is we go from this red mixture to this white pure aluminium oxide. What you would do is you would mix it, this dissolves, the iron 3 oxide remains behind as a solid, and then you could filter. The iron 3 oxide would be removed by the filter, would be the residue, and this would be the filtrate. Then this is further processed, but you don't need to worry about that at IGCSE. It's further treated to produce white powdery aluminium oxide. The aluminium oxide is given the traditional name alumina from its early days in chemistry, alumina, and aluminium oxide is then dissolved in cryolite. Now this is because aluminium oxide has got a very high melting point, so we couldn't really pass electricity through it at this temperature because it's just too high. So the aluminium oxide is dissolved in cryolite. That's this wonderful substance. Okay, sodium aluminium fluoride we could call it. Cryolite is its name. And that acts like a solvent, and the whole thing melts at about 1000 degrees C. So it lowers the temperature, and this makes it safer, and also it lowers the cost. Now let's have a look at the chemistry and the equations. We've got aluminium oxide now, which is a pure white solid, and we process it now to produce aluminium metal, which is a silvery metal. Okay, this is the setup where the electrolysis takes place. We have graphite anodes dipping down into the molten aluminium oxide, or it's dissolved in cryolite like we said, and you've got a graphite cathode which is the lining of the vessel. Okay. The molten aluminium forms at the bottom when it's made, and then it can be tapped off. Okay. What's going on? Well, overall, the aluminium oxide, by electrolysis, remember, electrolysis is breaking things up using electricity. The aluminium oxide is broken up into aluminium and oxygen. Now you'll recognize that that is not balanced. The slight problem is that this is an odd number, this is an even number, so we need a common multiple. We need to multiply the oxygen by 3. 3 2s are 6, so now we need to multiply that by 2. 2 3s are 6. 2 2s are 4. At the anode, what's happening? Well, what's going to the anode? Anions. Anions are negatively charged, so the O2 minus will go to the anode, and it produces oxygen, and it loses, each of these 2 minuses loses 2 electrons, and then the 2 atoms form an oxygen molecule. The graphite anode has to be replaced periodically. Why? Well, the graphite anode is made of graphite, carbon, and that carbon, especially at these high temperatures, will react with the oxygen that's made to produce, yes, you guessed it, carbon dioxide, which would bubble out, blub, 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 and disappear. But that means that this is slowly worn away. So the graphite anode has to be replaced. I think it's about every couple of weeks. Okay. And at the cathode, the aluminium ions, Al3+, go to the cathode. They gain an electron, they gain 3 electrons, and they produce aluminium metal. And that's what comes off at the bottom here. Okay. It's a beautiful process, really important in modern society. And aluminium, it's very abundant in the Earth's crust, and it definitely is one of those metals that will be used more and more. Right, read the pages and answer the questions.